Now please pay attention because we're going to count in octal, so please pay attention. So binary to octal means this is base 0 and 1. There is two base. We have 0 and 1 symbol, and we have 0 and we have symbol 0 to 7 in case of octal. So example 1, 111 F binary to something in octal. So what is this something? Answer is, we have 2 to the power 0 multiplied by 1 plus 2 to the power 1 multiplied by 2 plus 2 to the power 3 multiplied by 1 gives us 1 plus 2 plus 4 gives us 7. 7 is 7 in octal as well as hexadecimal both. 7 is 7 in decimal also. Now let's turn to a number where we got 4 ones here. So what is this x now? So one of the easiest ways to do it is to first convert this into decimal and then change it into octal. So octal or hexadecimal or whatever. So 2 to the power 0 multiplied by 1, 2 to the power 1 multiplied by 1, 2 to the power 2 multiplied by 1, 2 to the power 3 multiplied by 1. So we get 1 plus 2 plus 4 plus 8, and that gives us 15. Right? 8 plus 7, so that's 15. That's in decimal. And 15 in decimal is 17. Beg your pardon. It's 17 in octal. How? Okay. So how is this? So you see, 17 in octal. If you change that, 8 to the power of 0 multiplied by 7 plus 8 to the power of 1 multiplied by 1. So that gives you 7 plus 8, and it gives you 15. So 15. So your 15 decimal is actually 17 in octal. But let us now try to count this directly in octal rather than changing. So 2 to the power 0 multiplied by 1, 2 to the power 1 multiplied by 1, 2 to the power 2 multiplied by plus 1, 2 to the power 3 multiplied by 1. So we have 1 plus 2 plus 4. Now here 8 is not present in octal. We have 1 0. Remember? So just to show you, just like we have in decimal, 19 plus 1 gives us 20. In octal, 7 plus 1 gives us 1 0. Okay. In octal, this is what happens. This is in decimal. Okay. This is in octal. So 7 plus 1 is 1 0. Why? Because we have exhausted the symbols. So we come to 0 and then carry 1 to the left. So we have 1 0. So this is how we count. So when you are transferring directly into octal, I don't suggest you do this directly if you don't have enough practice, but I want you to practice this. If you have enough practice, you can directly change it to octal. So 1 plus 2 plus 4 plus not 8. No, there is no 8. There is 1 0. So we have 1 0 plus 4 plus 2 plus 1. That is 7. 1 7 octal. Simple. 1 7 octal. So direct change into octal. So that part is there. Now again, so another easy method. Okay, another easy method. It's a longer method. Another easy method, but a longer method, is to divide the total number of bits into the groups of the number of bits required to make up the base to which it is converted. I'll give you the example. So we're converting it to 8, base of 8. So we need 3 bits to make up all the digits of the octal system. Why? Octal system digits are 0, 1, 2, 3, 4, 5, 6, 7. That's 8 digits, and 8 is 2 to the power of 3. 8 is 2 to the power of 3. So we need 3 bits to make up 8 symbols. So we take 3 bits together, and the left hand side we take 3 more bits together. Now see, we've only left with 1. So what do? We put 2 zeros to the left. Simple. So this evaluates to 1, and this evaluates to 7. So we have 17, or rather, beg your pardon, we have 1 7 in octal. I keep saying 17. I'm sorry, it's a very common mistake. It's not 17, it's actually 1 7, because we use the same numerals as the decimal system. I keep making this mistake, sorry. It's 1 7 octal. How? Is 7 here, to the power of 0 multiplied by 1 plus 2 to the power of 1 multiplied by 1, 2 to the power of 2 multiplied by 1, that's 7. 4 plus 2 plus 1. And this 2 to the power of 0 multiplied by 1, that's only 1. The others are zeros, so those are zeros. I'm not even writing them. That's 1 here and 7 here. So write them separately. near 1/7, you don't even have to worry about converting, deconverting. However, this is a longer process, and it can be the it can you can do the same thing with the base 16 as you did with octal base 16. But base 16, how are you going to divide? Base 16 would have taken the entire 4, because base 16 is 16. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. 0 to 15 is 16 digits. 16 digits is, what is 16? 2 to the power of 4. So we take 4 bits together. And this would have come out to be 15, that means F. So 4 ones in binary make an F in hexadecimal. So this would actually make an F in hexadecimal. I'm sure you've converted before, and so you can verify this. The same thing you can do with hexadecimal as well. However, this kind of stuff, why am I going into the other stuff than the one that I've done previously? Because this is only available to you when the base that you're changing to is a power of 2. If it is not a power of 2, let us say, for example, you're changing from base 2 to base 49, from base 2 to base 3, then this is not going to work. So that is why I firmly believe that you need to do also. I mean, this is okay. If you're doing it in the exam, that is fine. If you're doing it when you need to, that is fine. But you should also practice doing this kind of direct arithmetic from base to base, or this kind of direct arithmetic preferably from base to base. Do it, practice it, and then you'll be so much better off at converting and deconverting, and it won't be any problem to you at all.